Hi, Mr. Richards here, and today's lesson is on inequalities. You'll learn how to write inequalities and how to graph inequalities on a number line. By the end of the lesson, you should be able to answer, how can I explain how to tell the difference between graphing an inequality with a closed circle and one with an open circle? Our first example is how to write an inequality. Your height is greater than 52 inches. Now what I like to do with these as we get started is say, okay, we have 52 inches. Well, bigger than 52 would be 53, 54 inches. Smaller would be 51 and 50 inches. And I go through and think, okay, my height is greater than 52 inches. What does that include? Well, is 50 here greater than 52? Of course not. Is 51 greater than 52? No. Is 52 greater than 52? No. Is 53 greater than 52? Yes. 54? Yes. And every other number bigger than that. So we set our variable h is going to be greater than 52. So for all our numbers h, like 53, 54, 55, and so on, it's going to be greater than 52. B, your speed is less than 62 miles per hour. Well, again, if we list our 62 here and a couple numbers larger, 63, 64, a couple numbers smaller, 61 and 60, is 60 less than 62? Yes. So 60 could be a speed. What about 61? Yes, that is less than 62. Is 62 less than 62? No. 63? No. 64? No. And so when you go to write an inequality, we could say, well, for speed, we might as well use S. And all of our speeds are less than 62 miles per hour. Now, our concept summary for inequalities, we have 4 symbols that we're going to use in this lesson for inequalities. We have the less than symbol, we have the greater than symbol, we have the less than or equal to with the line underneath our sign, and last, we have greater than or equal to. Now there are other phrases that go with each of these inequality signs. For example, with less than, we could also say fewer than. With greater than, we could say is more than. We could also say exceeds. For less than or equal to, we could say is no more than. And also, is at most is another phrase you may hear for less than or equal to. And lastly, for greater than or equal to, we could say is no less than is a phrase that could mean greater than or equal to, as well as is at least. All phrases you may hear with each of these inequality symbols. Now, what if we need to write an inequality? To meet a certain air quality standard, an automobile must have a fuel efficiency of at least 27.5 miles per gallon. Write an inequality to describe the situation. For this, we could always do what we've done on the previous one if we need help thinking about, okay, what numbers are true for this situation. If we start with 27.5, we can get bigger, 28, 29, and smaller, 27 and 26. So then we can look at, well, is 27.5, is that at least 27.5? Yes. Is 28 at least 27.5? Yes. 29? Sure. And this may be fairly obvious now, but is 27 at least 27 and a half? No. 26? No. So we're looking for our fuel standard here, F, to be greater than 27 and a half, but also could be equal to. So greater than or equal to. So F is greater than or equal to 27 and 5/10. Now, we can also determine the truth of an inequality. For the given value, state whether each inequality is true or false. For s minus 9 is less than 4, test it when s equals 6. Well, all that means is we're going to put 6 in for s. So 6 minus 9 needs to be less than 4. Well, what is 6 minus 9? 6 minus 9 is negative 3, is less than 4. Is this a true inequality? Yes, it is true. What about 14 is less than or equal to a divided by 3 plus 1? When a is 36. Well, here we're going to put 36 in for a. So 14 is less than or equal to 36 divided by 3 plus 1. Well, our left side's going to stay the same. 14 is less than or equal to 36 divided by 3 is 12 plus 1. And now simplify both sides. 14 still 14, and 12 plus 1 is 13. So is 14 less than or equal to 13? Of course not. So this answer is false. Now graph each inequality on a number line. We have x is greater than 10. So let's draw out our number line. We can put 10 in the middle here. And I like to think of at least one number larger and one number smaller. Now we can start with an open circle at 10. And then ask yourself, if I put 9 in for this inequality, is 9 greater than 10? No, it's not. Put 11 in. Is 11 greater than 10? Yes, it is. So we can shade the inequality to the right. Now what does this actually mean? Well, 11 is greater than 10 is a solution that is true. 12 is greater than 10 is a solution that is true. 1,000 is greater than 10 is a solution that is true. All these are true solutions on this number line, whereas 9, 8, 7, 6 are all false. Now when it comes into shading the circle, ask yourself, is 10 greater than 10? No, it's not. So it stays an open circle. What about the next example? X is less than or equal to 10. Well, really, we can just draw the same number line here with 9, 10, and 11. We'll start with an open circle at 10. And again, we can test. Is 9 less than or equal to 10? Well, it is less than, so that part's true. Is 11 less than or equal to 10? Well, no. And so we'll shade towards the 9 to represent all the numbers smaller than 10 being true. Now for our last test, is 10 less than or equal to 10? Yes, it is. So we can actually shade in this circle to represent the fact that 10 is less than or equal to 10. So for this one, 10 is less than or equal to 10 is true. 9 is less than or equal to 10 is true. Negative 34 is less than or equal to 10 is also true. I mean, all these are solutions of this inequality. Now what about 8 is greater than x? One of the dangers in graphing inequalities is sometimes we make a mistake of assuming it's always going to be shaded in the direction that our inequality is pointing. That is not always true. In fact, that's probably true just about half the time. So instead of trying to memorize a rule of which way things are going, just draw each one of these out and put some thought into it. We'll have 8 in the middle, number larger, number smaller, so 7 and 9. Let's put an open circle at 8, and then test our numbers. Let's put in the 9. Is 8 greater than 9? Well, no. For 7, is 8 greater than 7? Yes, 8 is greater than 7. So we can shade our inequality towards 7 and all numbers that are smaller than 8, since all numbers smaller than 8 are true. And when it comes to shading the circle, well, is 8 greater than 8? No. So we keep the open circle. In fact, there is a rule with these. For less than and greater than, we're going to keep an open circle. However, for less than or equal to or greater than or equal to, we're going to have a closed circle on the number line. This is one shortcut I don't mind you learning. Notice how if we have that little extra line underneath, the or equal to, we shade the circle. If we don't, well, we don't. Now when it comes to writing inequalities for the graph, I'll draw us a few graphs here, and we'll see if we can write an inequality for the graph. 7, 8, 9. And if we put an open circle at 8, and shade it back to the smaller numbers, we can just set a variable x and say less than 8. And we have an open circle here at 8, so this is just going to stay less than. So we're saying all the numbers are going to be less than 8. Now we haven't dealt with too much negativity or negative numbers yet. So what if I did negative 9, negative 8, negative 7, put a closed circle at negative 8, and went towards where the numbers are larger? Well, here we could say we're looking at x, all the numbers that are greater than or equal to, since we have the closed circle, negative 8. And lastly, we can dive into the world of fractions. We could have 1/4, 1/2, 3/4, with we'll go closed circle at 1/2, shaded towards smaller numbers here. And so x would be less than or equal to 1/2. That is it for this lesson on inequalities. Good luck.